Okay, number 55, Hooke's Law questions. Essentially, when you're doing spring questions or any force questions, remember the process is your free body diagram and your net forces. And now we just have another force that we can put into the mix, Hooke's Law, right? So now we have gravity, we have friction, we have Hooke's Law, and so on. So let's take a look at this person. Here's the person on the pogo stick. And what happens is I'm just going to put a little springy thing here. That'll be the pogo stick spring, okay? What are the forces that we have? Well, we have a force of gravity, which is pulling down on this person. That still exists. But now there's a force of the spring. When the spring is compressed, it's going to want to restore itself, the restoring force. It's going to want to push itself up. So the upward force that we have here that's working against gravity is the spring force. Okay? All right. So let's do our F net X. Or in this case, I guess we could do it F net Y. And we have the spring force and the gravity force working. So now that you know this, the spring force is up. Its value is Kx. And gravity is down, mg, so you can put the appropriate numbers in for those. And of course, ma is the acceleration. And they want you to find this acceleration. So now that I've helped you set this up, you should see that you have a mass for this number right here, and you have a g for this number, and it looks like you have an x and a k. Those numbers are given in the question. And again, here's the mass. So you should be able, using the F net equation, to figure out what that A would be. So give that a whirl and see if you can come up with the right answer. And remember, the free body diagram is critical for every force question, as is the F net equation.